Welcome, everybody. So, Jimmy is probably the speaker that traveled the furthest just to be here on stage in front of you. He came all the way from Tasmania. And his favorite movie is Blade Runner, the new one, 2049, both for making it feel part of the original world, while also creating something new. But I also have a feeling he likes the Harry Potter universe for some reason. You'll see why. Please join me in welcoming Jimmy to the stage.
Cool. Hey, good afternoon, everyone, and thanks for coming to hear me talk about builds and deployments, of all things. So I'm Jimmy. I work as a developer at Atlassian. I'm in Hufflepuff House. That's my new gate. There it is from the other side. So today, we're talking about why builds and deployments matter, and how to fix them when they go bad by making them documented, debuggable, documented, definitive, debuggable, and Deft, in quite broad terms. So my new gate, it's pretty nice, don't you think? I mean, it's nothing too fancy. The access hole they cut for the bolt's a little bit rough, but it swings really smoothly and effortlessly on its hinges. The bolt sort of slides closed with a nice, satisfying clunk, and it's nice and low and flush for the ground to keep out the wallabies. I'm quite serious. Where I live in Tasmania, you have wallabies just hopping down the road and into people's backyards. We got the whole fence done, actually. There were palings coming off, and the neighbour's dog could sort of poke her head through for a pat. It was in a bit of a state. So they came, tore down the fence, and then their hole boring machine promptly broke down, had to get parts in from Canada, and we're about 3 weeks without a fence. But it was nice when they finally did get the job done. And we're quite happy with the new gate. Anyway, I think you've heard enough about my new gate, hey? This is my old gate. You can see it's kind of coming to pieces there. This post is supposed to hold stuff up, but it's completely disconnected from the rest of the fence. And you can see some birds thought it'd be a good place to perch after they'd gorged themselves on the nectarines from our tree. So, it functioned just, but it was a bit of an embarrassment. It sort of detracted from the overall aesthetic of the house. And you might wonder about the build quality of the house, just looking at the gate. So anyway, all this business with gates has led me to develop a little theory. So show of hands, who's heard of the broken window theory? Yeah, so this one's not mine. But this one stems from a phenomenon observed in urban neighbourhoods where a single broken window in a building can lead to the impression, if it's not attended to quickly, that no one cares. It can lead to further neglect and vandalism in a kind of vicious cycle that can even cause more serious crime in the neighbourhood. So the theory goes that in the same way, code that is neglected will breed more neglect. So this theory is from The Pragmatic Programmer by Andrew Hunt and Dave Thomas. And as they put it, neglect accelerates the rot faster than any other factor. So they call this kind of decline in code quality code rot. So building on the work of Hunt and Thomas, allow me to introduce the all-Australian dodgy gate conjecture. So my very own dodgy gate conjecture holds that your build scripts and your deployment scripts are not exempt from the broken window effect. And the reason I gave it that name, the dodgy gate conjecture, is I reckon your builds and your deployments are a bit more like a front gate than they are like a window. So how so? Well, it's true that a gate lets some things through and keeps other things out, just like your tests keep out regressions, let through features for production. But that's not really what I had in mind. Instead, think about a newcomer to your team. Whatever other part of the project they've been assigned to, sooner or later they're going to have to contend with your builds and your deployments. It's going to greet them as they approach your project. And when they walk down the path through the gate and onto your turf, what kind of first impression will they get? Will it give off an air of care or of neglect? Will it be polished and swing gently on its hinges, like my new gate? Or will it be sort of rusty with flecks of paint coming off, squeaking and groaning and straining as you try and force it open? So that's a bit metaphorical. In more real terms, when this team member comes to make their first commit and it triggers off a build, what will the result be? Will the result find them in some kind of sensible notification, a target notification in their chat client? Or will they have to go looking for it? If it fails, will it be a genuine failure or just some kind of non-determinism or environmental factor? If they're a good sort who actually takes on themselves to try and improve your builds and deployments, what will that experience be like? How far will they get before giving up? If they need help, will they look for it in the README? Will they find it in the README? Or they have to go and ask a team member, and will the team member have a quick answer for them, or just kind of a sheepish and apologetic shrug? And all of us have to contend with our front gate in our daily project comings and goings. And if it's not well maintained, it'll slow us down when we have more important places to be and things to do. So what are some signs that your builds are this? Like, it's pretty easy to sense, but I think it's still good to go through the list of some issues we might face before we jump into solutions. So first, let me tell you a bit about the project I've been working on for over a year now. Hands up if you've ever been to developer.atlassian.com. Cool, yeah, most of you, I'd say. Yeah, so that's what I've been working on, the stuff that you see when you go to developer.atlassian.com. We call it DAC for short, developer.atlassian.com. So we took this over as a pre-existing project. It was basically just a simple site generator. But under our watch, under quite tight deadline pressure, we saw it take on a whole raft of new responsibilities, like the app management portal you saw in the keynote briefly, REST API browser, and even a mechanism for other teams to contribute documentation in and sort of aggregate it all up together. And like I said, it was under tight deadline pressure, so we didn't have a lot of time to think about what we were doing to our code and our builds. And so needless to say, I think we've experienced pretty much all of the anti-patterns I'm about to go through here. So I think we've sort of gotten all our mileage out of the gate metaphor. So like Peter said, finally, it's 2018, I finally discovered Harry Potter. I thought it was pretty cool. So maybe we could turn to the wizarding world for some inspiration as we think about these build anti-patterns. So first, the chamber of secrets. What goes into your build to produce the final artifact? What variables determine where and how it's deployed? What about credentials? What credentials do you need? If they expired or compromised, even worse, how would you reset them? How would you give a new team member access to them? If your answer to any of these is, I don't know, well, you might have vital information locked away in the chamber of secrets. So like I said, we took over the project quite hastily. And there was some stuff that wasn't necessarily handed over, and we found that when we needed that information urgently, the person who knew was generally asleep in another time zone or even on vacation. But there was a more pernicious kind of secret knowledge that bit us, which was the undocumented environment variable. And one such variable actually caused us to lose analytics for a couple of days. The chamber of secrets had struck. Next, the dark arts. So how easy is it to understand your build pipeline from start to finish? Do you need to go to your build server and sort of click through step by step, look at the scripts it's calling, try and keep it all in your head? Is there a big pile of shell scripts in the root of your repository? Are you pretty sure some of them aren't used, but they all kind of call and depend on each other in a rather complex web that you've never quite got your head around? So you're a bit too scared to delete any of them. If so, your builds may be employing the dark arts. So as our code grew in complexity, so did our scripts. The shell scripts piled up in the root, and because we'd never really taken the time to fully understand the builds, we just kind of made a more and more tangled web that just made things harder to untangle when we finally took it on. Not much needs to be said about the time turner. These are the kind of builds that turn your valuable time into wasted time because it takes so long. You know, the kinds that make you want to get your feature finished and pushed before lunch so you can check the result when you get back. Our builds went from about 29 minutes to about 59 minutes, not to say nothing of the build artifact size. And there were quite a few surprising sources of slowdown along the way. When your build fails, do you just reach the rerun button assuming it's one more false negative? Do your builds spend half of the sprint in the red? Are you suffering through the half-red sprints? Thankfully, our project has mostly avoided too many non-deterministic tests, flaky tests, but bloated builds running out of resources, and the next anti-pattern I'm going to speak to you about have caused these half-red sprints for us. So lastly, the deathly dependencies. If you build a given commit from your repo, from the same commit, do you always get the same artifact, or the dependencies shift underneath it depending on what's cached? And now this sort of depends on what ecosystem you use as to whether this will affect you. But certainly in our original naive NPM-based solution, we would get this. Sometimes we'd get a green feature build, like a green feature branch, merged into master, and lo and behold, slightly different dependencies were in the cache on that agent, and it went red. So are any of these sounding familiar to you? Maybe all of them. Well, don't despair. Like I said, we saw all of those in one shape or form or another. And over the course of about 2 months, we were able to rectify most of these without actually pausing our backlog work. So, probably feeling ready to get to work on some solutions now, but maybe you're thinking, where do we start? And for sure, it can be pretty daunting to figure out where to start when we're dealing with months or years worth of mess. On the other hand, maybe lucky you're starting something new and you want to avoid the mistakes of the past, and you have a whole bunch of ideas about how to make the perfect build and deployment pipeline. But again, where do we start? So, as the title of my talk suggested, I think we do well to start from the simple principle that our builds and our deployments are code too, and code has standards. I'm sure that your production code has some kind of guidelines or standards or a framework that you use. It might be adapted in full or in part from a popular, widely used one like clean code, or it might be your own. So if our builds are code too, why can't they have the same kind of standards? Not necessarily the exact same thing, but some kind of framework or blueprint that lays down the kind of expectations you have of your build and deploy code. So I'm going to sort of talk about kind of our way of thinking about our builds and deployments, which you might want to adopt or adapt or salvage for your own builds. Now, this calls to mind a far older kind of wizarding, the kind that might require you to roll a 20-sided dice and add your ability modifier, because it is the 4 Ds, as I call it. It's 4 qualities that make for good builds and deployments, and they work pretty well if you apply them one after the other, top to bottom, like a kind of renovation plan. So you saw them briefly in the agenda. Here they are again. Make your builds documented, then definitive, then debuggable, and then Deft. A quick aside to address something I won't have time to talk about, so I hope you're not here to hear just about this. Test determinism. So if you have tests that sometimes pass, sometimes fail, regardless of changes you make, that's definitely going to be a thorn in your side, but not something we have time to talk about today. It's too big of a topic to try and cover. Hopefully by the end of these 4 Ds, you have a really nice tight dev loop of your builds and you can quickly root out these flaky tests. But if you do want an in-depth coverage of this topic, I recommend a talk called Automated Test Hell by Wojciech Saliga. He was a fellow former Jira developer who put in a heroic effort to tame those decade-old tests. He's actually here at the conference, I believe, so you might see him around. But I think 4 Ds will be plenty for us today, so let's get started. Yeah, I know. Documentation. I mean, I'm really pushing it. You've done the courtesy of coming along to hear me talk on so dry a topic as builds and deployments, and straight out of the gate, documentation as well. I mean, most of us, hands up if you love writing documentation. Yeah, so most developers, we're not so keen on documentation. We'd rather get straight to work, doing something real, writing some code. We're agile. But, I mean, yeah, I know, documentation. And maybe, should I just tell you some more about my gate? But just hang in there, kind of like my gate was doing, okay? We need a bit of discipline. After all, we're a team. We're professionals. We need to plot some kind of course together. Otherwise, we're going to wander off in different directions and get lost. It'll save us time, and it'll get us a better result in the long run. Because documentation distills your thoughts. So another call out to another talk, Hammock-Driven Development by Rich Hickey, the creator of Closeout. If you're in the Tech Radar talk, I think Diogo mentioned this as well. So he puts the case much better than I could for when you're approaching a new problem, stepping back, thinking things through, weighing up your alternatives, and writing things down to distill your thoughts. So just to talk quickly about another project I've been on, which is a Greenfields project called the Consent Screen. So this is part of the OAuth 2 solution we've just announced for Jira. By the time it came time to work on the consent screen, I'd been on DAC for a while, and I was pretty fed up with the builds. I was pretty ready to do things right this time. But how could I ensure that the consent screen builds didn't follow the same trajectory and gradually decline? Well, I had at my disposal a tool that's been around for thousands of years. I could write something down. I wanted to use documentation as a means of forethought, not an afterthought. You may have heard the term README-driven development. That's what I was going for. So one of the first PRs I raised on this new project was just a README file explaining, laying out the rules of engagement for the project and talking about builds along with everything else. So here are my rules of engagement. You don't have to agree with me on these rules. You just have to agree with your own team on your own rules. Just write a few things down. It's the easiest thing in the world. I might touch on number 3 because it's a bit of a pet peeve. We'll see if we have time. So, I got to work, I built the tests, I was pretty happy with it all, but it was kind of complicated because certain regulations we comply with mean you need a controlled environment to build your product, and we also needed a controlled environment to build the environment that built our stuff because we wanted a custom environment. So it was pretty hard to pick up just from the code. So I added another README file, and there's a pro tip for you. You can have more than one README in your source repo. So don't worry if you can't read the text. Just understand that this is the layout of our code in kind of a text-based diagram. So you might think it looks a little bit fiddly, it would take a long time, but really it took maybe 20 minutes. I think it took less time than it would take one other developer on the team to have understood everything if they hadn't had this diagram. So it paid for itself pretty quickly. And the team appreciated having something like this to refer to as well. So here's a comment I got on the PR. High praise. I also just laid out the directory structure. I checked this recently, and it's as I was writing the talk, and it still applies. So I know documentation can go stale sometimes, particularly comments, and I'm as firm a believer as any developer that clean code can speak for itself. But surely there are some concepts, some ideas that can't be easily expressed through code alone, and for those we have comments and diagrams and documentation. So that was a greenfield project. What about established projects? Well, I think you still do very well to sell your vision, to lay out a future state that you'd like to see your builds and your code attain to. But you're going to need a bit more documentation as well, I think. It pays to describe the way things are today and document the status quo. And there are a few reasons for that. Obviously, you need to make sure you really understand your builds before you try and recreate them. Otherwise, how do you know you haven't missed something? Also, when you describe them another way, it'll help you spot opportunities for optimization that you might have missed. And it might even help you build a case for scheduling time to work on your builds and deployments. Because people might sort of not assign them a lot of value, but if they see just how long they're taking, just how much of a mess they're in, they might see more value in it. So it might be enough just to add a README file, add some comments to your code. Developer.atlassian.com was in a more serious condition. So I'm about to show you a diagram I made to lay out how the builds worked for developer.atlassian.com. But you may find it unsettling. You ready? Here it comes. Yeah, don't try and read it, don't try and understand it. So that's a pretty epic diagram for a pretty epic build, all to put some documentation up on the internet. And that took a bit longer than the other diagram, I must tell you. Nevertheless, I think it still paid for itself in the shared understanding it engendered. And again, the team liked it. My team lead actually commented and said, I feel like I should print this out and put it on a wall. And lo and behold, he did just that, true to his word, and there it remains to this day. So there's A3 sheets of paper, and there's 8 of them. And funnily enough, it was about this time that the idea of renovating our builds started getting a lot more traction. I think even the dog is kind of a bit shocked and outraged at what we've done to our builds. So I hope your build process isn't like that, but it probably still pays to get your bearings. Once you've gotten your bearings, you can chart a course. For us, we charted that course by writing up a high-level plan on Confluence that turned into an epic in our backlog, turned into a series of issues, that turned into a shiny new set of builds. But it all started with documentation and communication. So onto D2, definitive. So if you've been following tech trends, you probably know that immutability, containerization, code have really made inroads into the infrastructure space, and with good reason. Our systems are hard enough to get our heads around without taking into account disparate OS versions and runtimes and states. So we had Chef and Ansible and Puppet and the like, sort of letting us gather up our infrastructure recipes into our code base. Then we had Docker and Kubernetes that sort of took us to the next level with containerization. So builds are code too, so why can't they get in on the action? So what I'm saying is maybe how and where your build runs should be defined in code or config, not in the user interface of your build tool. So speaking of our products, in Bamboo there's something called Specs, which is a native feature, which I recommend you check out if you want to do config as code there. In Bitbucket Pipelines, everything's controlled through a config file anyway. We just choose your Docker container, some memory settings, some caches you want available, and yeah, that's the only way you do it. So we inherited the DAC project. It was all just sort of configured via the Bamboo user interface. And we pretty soon started to notice some shortcomings of this approach. For example, like I was talking about before, we had to sort of click through the individual screens and try and sort of hold it all in our heads. But probably even worse was if we wanted to make any kind of change, we had to pay careful attention to what we were changing and what we were changing it from so that we could roll back. Of course, in code, that is a solved problem. We have Git. And it's really nice, yeah, just to have everything laid out in configuration as code, to have it right there in front of us, easily comprehensible. So we did that. We used a single file called builds.groovy for all our builds. So once we had our config as code, we were able to just give it a different name and different key, create a whole new set of builds that we run in parallel. It was configurable to be deployed to a different environment, and so we ran both of them for a couple of weeks until we were confident that the new builds were correct. Then we were able to cut over and gleefully delete the old builds. So that's part of the problem. That's part of the solution. The other side of that, of course, is controlling your environment, because you may have different build agents that will give you different versions of executable. That's another source of non-determinism. Or even if they're all the same, you're going to be limited in what kind of tools you have available for your builds. So the solution to this quandary is to run your builds in a Docker environment. So Docker is a topic worthy of a whole conference, but just in case anyone's not across Docker, I'll try and summarize it really quickly. It lets you run your stuff inside containers, which are like really lightweight virtual machines, determined by a template called an image, which is described by a Docker file. You run a container once and you throw it away, and you run it on your computer, which gets called the host. So it's really liberating to use this kind of approach for your builds, because you can have whatever you want. You can either pick a pre-baked image, or you can even build your own. And you're no longer at the mercy of your build agent configuration. So again, Bamboo and Bitbucket differ in how you do this. You might want to use the per build containers plugin in Bamboo. Oh, that's pretty heavyweight. You might get away with just using multi-stage builds, and I'll talk about that next. On the other hand, Bitbucket is all Docker-based, so if you're using that, you're already set. So here's the aforementioned multi-stage build. This is how we did it in developer.atlassian.com. So you can see you've basically got two halves to your Docker file. You've got your build environment and then your production environment. So in the build environment, you grab everything you want. You don't worry too much about size. Just take all the tools you need to do your build in the way that suits you. Then halfway down the file, start again. Just grab the build artifact and copy it into that new image. And that's what you use in production, a nice lightweight image. Now, certain things won't be available, like primitives for getting hold of a certain version of an executable, like you have in Bamboo. But because we control the whole environment, we can just call things directly. We set up our environment variables, and we let the code do the rest. Speaking of environment variables, that's the next thing you should get bedded down. So it might be that you're all across this, but we certainly weren't. So like I was saying, in the process of migrating our builds, we lost some analytics. And we lost them because we had something called the Webpack environment variable plugin. I'm not sure if you've used this before, but basically lets you, from inside your front-end code, reference environment variables as if you're in Node. Then Webpack comes along, replaces these with whatever the environment variables are set to during the build process. That's the theory. That's how we got hold of our analytics SDK key, because we had different environments. But when we were migrating our builds, we forgot about this environment variable. Suddenly, our analytics went to the browser log instead of the pipeline. So the answer to this kind of issue is, of course, to make sure you've done the first D, you've documented all the environment variables that go into it, and then you just check them all up front and fail straight away if they're missing. So this is what we did in DAC after our analytics slip-up. So in Docker, I don't know of any way where you can force Docker to check all of the build arguments for you. But it also sets environment variables to match these build arguments, which are how you sort of feed in different configuration to a Docker file. So you have your arguments, and then all you have to do is run something like this bash command, test that the environment variable is not null or empty. And if it is, then it goes on to the next command, which just returns an error and returns a non-zero code, and that causes Docker to exit. And you notice we're not only talking about what's missing, we're explaining where to get it. So at this point, you'll obviously need to know where to get all your credentials and stuff yourself. So hopefully you have some kind of solution like LastPass for controlling access and configuration of your credentials. And then basically what you can do is someone can try and run the build locally, and they can just follow the error messages until they've got something working on their own machine with all the information they need. So that's the kind of thing we retrofitted into DAC. But in our more greenfield, arguably gold-plated consent screen service, we had something more like this. So this is sort of a cut-down representation of what we had. But it's a function written in TypeScript that basically checks whether it's running in kind of a Bamboo build context and returns an object representing that, or it returns null. And it fails if some of the variables are there and some of them are missing. And that way the calling code can proceed knowing whether you're on Bamboo or running locally, and proceed accordingly. So this is a great kind of thing to have if you want to have debuggable locally running builds. If you're paying close attention, you might notice there's no credentials getting pulled in there. That's because we have a whole other function like that. Because if you're using real code to write your builds and your deployments, you can have that kind of stuff. You can have single responsibility functions and abstractions. So this makes sure we're authenticated against our internal Docker hub. So either we've got something in the configuration file, or if that's not there, it'll present a prompt, assuming that, again, a user's running it locally. The client code doesn't need to know how it's authenticated, though, but it can proceed with confidence knowing it is authenticated, and it's not going to go to all the trouble of building the whole artifact, only to try and push it and get rejected with an unauthorized error. So the point I'm trying to make is, with this kind of setup, we've laid a foundation for making our builds debuggable. So builds are code too, so why shouldn't you be able to debug them? And why, in theory, couldn't you even start it up and attach a debugger? We've got Docker. We know what environment variables we need. Really, that's the whole recipe. And because we have Docker, we can actually use any language we choose. We don't have to use Bash. So at this point, I was going to go on like a long tangent about maybe why you shouldn't use Bash and why I don't like Bash, but I don't have time for that, so I'll spare you and give the accelerated version. You may say Bash works anywhere, it's portable. I'd say it's not really true, and it doesn't really matter, because we've got Docker, so portability doesn't really matter. You can get whatever tool you want. And then I just had some examples, like this depends on whether a certain setting is on or off. You could try and set it, but you might have the wrong version of Bash, particularly if you like developing on OS X and building on Linux. There'll be lots of differences like this. BNSH might be a nice reduced subset, or it might just be resolving to Bash anyway. Well, you might say, okay, well, Bash makes it easy to work with files. Well, it depends on the work you're doing. Like, are you parsing JSON? Then you're going to need some kind of external non-portable tool. Like stuff like sed isn't actually portable either. On the other hand, I think it sort of gets overrepresented how hard it is to work with files in other languages. Like we use TypeScript in the consent screen, and we just have single responsibility functions. So there's a few lines in each of those that lets us work with files, call it from anywhere. It's really not a big deal in the scheme of things. It's just a little script, little things, big things grow. Maybe this is you, Maybe you love Bash, maybe you're convinced it's the tool for you. And I'm not going to stop you from using Bash if that's the case. Go on, good luck to you. Personally, when I use Bash to write stuff, I get this. But maybe you have more luck. If you want my recommendation of a tool that's already at hand, that has batteries included, SDKs, easy to read, is portable, I say maybe my preference is for Python. However, in fact, in Python you can even attach an interactive debugger. But anyway, speaking of that, we were talking about debugging. So again, these are your ingredients for having a locally running, reproducible, debuggable build. We know what environment variables go in. We have our Docker containers, which we can run anywhere we have a Docker daemon. And now the last thing we need is just a script to just join those two together. So provide the environment variable start Docker. If certain stuff is hard-coded in your scripts, you might need a few more environment variables, but that's no sweat. And then, of course, you just need access to your source repo, which you can do any number of ways. So this is how we did it for the OAuth consent screen. You can see we have our build container and our deployment container, and a script that starts both up with Docker Compose. We have a shared directory, which is mounted on both of those. And then we have configurable scripts. So tell the build script to put the artifact in this folder, tell the deployment script to pull it out, and to deploy to this test server. And there we have like a really faithful representation of our entire pipeline running in our local machine. So you run the script, you get some more documentation in the form of output complete with emoji, just telling you how to get started. So it pays to think about the developer experience, even if you're just writing your builds. Because the easier it is to work on your builds, the easier it is to make them deft. Deft meaning clever and quick. So now we have this script which just sort of runs our builds and deployments. We could expose a port and attach a debugger. We can sort of stop it and restart it at different points. We can tweak it. We're not waiting for a job queued on a remote server. We have this really nice, tight dev loop. We can iterate. We can improve things. So what follows is a bit of a grab bag of things that we added to our builds once they were really easy to work with. So you might discover that parts of your build, with a little bit of tweaking, can be run in parallel. In Bitbucket Pipelines, just search for parallel steps Bitbucket Pipelines, and you'll find out how to do this. Probably just a few extra lines. So we use this to get really good, quick feedback when we were reviewing PRs. We had parallel steps to lint, to run the tests, to check that the yarn log file wasn't polluted, and even to upload some storybooks. So if you're not a front-end developer, basically a storybook just lets you show different UI components in various states to see how it looks and test it out. So Dimitri, a colleague of mine, wrote this great script that just built the storybooks, uploaded it to a static host called Netlify, then added a link to this storybook right there in the build results, which show up in the PR. So just open the PR, click on a link, and you've got all the UI changes right there to review. No more checking out the build, checking out the source code, building it and running it, which our designers in particular weren't too keen on having to do. Dimitri did write it in Bash, so I was a bit disappointed about that, but I got over it. Next, a shared build base. So as you saw, the DAC build was getting pretty complex, and actually we needed 3 things out of it. We needed like our main service for authentication and proxying. We needed a service to serve the static documentation, and we needed what we called live preview, which was a local container that our doc contributors could run so that they could see their changes without having, again, to build the whole system. And originally, we were just kind of building roughly the same, like slightly different things 3 different times, because again, we didn't really understand our builds. But once we had config as code, once we had a good handle on it, we could just build everything in one go and then just split it out into its components. So our service, for example, to build that, it just became a string of copy commands. And again, a kind of like a multi-stage build. So yeah, we also added some smoke tests for live preview because some users were discovering it was broken before we did. They weren't seeing their changes updated. So again, we could have added this beforehand, but it was much easier once we had config as code to see how to do it. And likewise, we could separate out a part of our deployment that uploaded the newest Swagger files to Postman so that you could sort of download the whole thing in one go and test it out. Before, everything was sort of wrapped up into one big script, and maybe like a network failure or something like that, something intermittent like that would fail the whole build. And really, uploading the latest Swagger file wasn't the most critical thing. So we could pull that out, retry it, and run it separately. Not sure what it is for you, but yeah, just having really nice to work with builds will unlock all sorts of possibilities that you probably wouldn't have attempted if you have to wait for your build to sort of go to Bamboo, get queued, get run. So the developer.atlassian.com site is always evolving, often quite drastically. And I think that taking this time to renovate our builds has really given us energy and momentum and confidence to keep pushing forward with all the new feature requests. I don't know if you could really call our builds like deft or delightful yet, but I'd say we're getting there. On the other hand, the consent screen builds were very deliberately set up, and they really haven't given us any trouble. There's more we could add, like maybe more post-deployment verification. But I'm confident that if we want to do that, it should be a breeze. So, there we have it. What a long way we've come on our D&D and D&D campaign. I hope something there has struck you as just what you need to start taming your unruly builds. So to sum up, again, just remember that principle. Builds are code too. Builds and deployments are worthy of our attention because they're part of our code base. And if we give them the chance to shine, they can be a testament to our attention to detail, like a shiny new gate. They can be a feather in our cap. They can be a well-oiled machine, precision engineered to handle our precious commits. And if we don't give them the attention they deserve, they'll steal it back from us later. So yeah, that should be a takeaway from the talk. Take care with your builds and deployments. Do them justice and be a professional. So thank you, and that's really all I had to share with you. I think we've got a bit of time for questions. Otherwise, if you want to know some more specifics or have any other questions, feel free to find me after. Thanks.
Thank you very much, James, for that. Jimmy, I'm looking forward to the deadly dependencies part 2. So we've got time for one question. Who's first? Nobody? Okay, then it's early coffee. Thank you very much.
Sorry. I think I see a question.
There we go.
I have a question about Bamboo specs. What language do you suggest for that one? Start with YAML or Java or just the YAML script or?
So it's all JVM-based languages, is it?
Yeah.
Cool. So yeah, we actually use something called deployment build plan templates, because I think we didn't have specs available at the time, so that was kind of a precursor. But I mean, my bias is towards strongly typed languages. If I was just like trying it out, I'd probably try Kotlin if that's supported, just because that seems like it has good typing, good semantics. So I'd say go with something with types, because they'll save you, they'll help you write like real production quality code. But yeah, I haven't actually tried specs myself, to be honest.
Thank you very much. And that's it for today. Well, for now. Sorry.